Okay, so like I said, when we have a problem and we want to solve it using dynamic programming, the first thing we do is construct what is called the DP table. And the dimension of this table, as in whether it is a single row or some rows into columns or a three-dimensional thing, that depends on how many inputs you have in the problem. So if you look at this problem, we have two main input parameters. One is your exchange value and other is D, the set of denominations. So if you take our example which we saw during the problem definition, exchange value was 19 rupees and I think the denominations were 1357 if I'm not wrong. So E is equal to 19 and D would be a set containing 1, 3, 5, 7. So because we have two input parameters, our DP table will be two-dimensional. So it will have E columns and D rows. The columns will correspond to exchange values starting rupees 1, 2, so on up to your E. And I'll show you a picture of what the table looks like right now. And the rows will represent the denominations in ascending order. So initially when you set up the DP table, this is what it will look like. So as I said, each column represents one exchange value starting from rupees 0, rupees 1, rupees 2, so on up to rupees 10. Yeah, this is the example for which I'm drawing. I'm sorry, I forgot to draw your attention to that. So here our exchange value is rupees 10 and the denominations allowed to us are rupees 1, 2, 4 and 5. So for that, this is what the table looks like. Each column represents one particular exchange value, 0, 1, 2, so on up to 10. And each row represents one of the allowed denominations, 1, 2, 4 and 5. And 0 row and 0 column they're a base case sort of. When you have recursion, over here you need a base case, which is why we have this 0 row and 0 column. You can think of it as a dummy row, for instance. So now, what does the number in this cell or in any cell of this table represent? DP of I of j represents the minimum number of coins of denominations D1, D2 up to DI, this being a keyword, required to make rupees j. So we'll go back to the table and I'll explain. So if I say DP of 2 of 6, I'm talking about this cell here, 2 of 6. It means the minimum number of coins required to make rupees 6 using the denominations 1 and 2. And by 1 and 2 I mean I can use 1, I can use 2, I can use a combination of both. The confusion which most people have over here is, when I say DP of 2 of 6, they think it is the minimum number of coins required to make rupees 6 using 2 rupee coins alone. That is not the definition. DP of I of j is the minimum number of coins of denominations D1, D2 up to DI required to make rupees j. Right, so we were looking at how the DP table is initially set up. Again, every column represents the exchange value, and why we start from 1, 2, 3, 4 and go all the way up to 10 is, like I said, the solution to 10 will depend in some way upon the solution to 9. That will again depend in some way upon the solution to 8 and so on and so forth, which is why we start from 0, 1, 2, 3 and go all the way up there. And the rows represent the denominations. DP of I of j, like I said, represents the minimum number of coins required to make rupees j using any or all of the denominations from 0 up to I. So that's the initial setup, and of course the 0 row and 0 column are obviously going to be filled with zeros, because if your target value is 0, you don't need any coin at all. And if the only denomination allowed to you is like empty, 0 is not a coin per se, right? So it's like no denominations are given to you at all, then again you cannot make any coins. So it makes sense that the 0 row and 0 column are filled with zeros. And the 1 row and 1 column, again, the 1 column means your exchange value is 1, which means obviously you just need 1 coin of rupee 1, whatever your allowed denominations may be. And the 1 row means the only allowed denominations are 0 and 1. 0 obviously we do not consider. So the only thing you are allowed to use is 1 rupee. Then you will obviously need 1 coin for rupees 1, 2 coins for rupees 2, so on and so forth, up to 10 coins for rupees 10. So these are the base cases which we can directly fill in from common sense without having to use a formula or what I call the optimal substructure. But yeah, and that is exactly what this paragraph here talks about. Zeroth row and column are filled with zeros for obvious reasons. If you have a row corresponding with denomination 1, then each column takes the value equal to the exchange value. So this column takes a 1, this column takes a 3, and so on, for reasons which I just explained now. And generally, dp of I of j is equal to dp of I minus 1 of j whenever I greater than j. So I'll explain this line. This is an important base case to understand. So whenever your denomination becomes greater than your exchange value, you're obviously not going to be using that denomination, because as we saw in the constraints, the total amount should be less than equal to the exchange value. So let's say I come to this cell dp of 2 of 1, row 2, column 1. Now my exchange value, or the amount of money I need to pay, is rupees 1. The coins I am allowed to use are rupees 1 and rupees 2. Now 2 is greater than 1, so obviously I am not going to be using a 2 rupee coin. So what I'll do is I'll just look at the value in the previous cell and I'll put it back here. Similarly, if I come to say dp of 4 of 3, I need to pay 3 rupees. I am allowed to use 1, 2 and 4 rupee coins. Now I will obviously not use a 4 rupee coin when I only have to pay rupees 3. So what I'll do is, I'll look at this value here, which is the minimum number of coins required to make rupees 3 using 1 and 2 alone, and I will just copy that value and paste it here, which is what this formula here says. dp of I of j is dp of I minus 1 of j, the previous row, the same column, whenever I denomination is greater than exchange value. These are the base cases, and this is how we set up the dp table.